Good afternoon, everyone, and welcome to Technical Safety BC's first webinar of 2024. Today's topic is heat pumps, regulations, requirements, and certification. My name is Karen Stainton. I'm a business partner of education on the client education team, and I'm going to be your moderator for today. I am coming to you from the ancestral unceded territory of the Coquitlam Nation and recognize that I am an uninvited guest on these lands. The Coquitlam people are the first peoples of the Coquitlam watershed. Archaeology findings have confirmed continuous occupation of ancestral lands for at least 10,000 years, or since the last ice age. The cities of Coquitlam and Port Coquitlam take their name for these peoples. The Coquitlam people are descended from ancestors who were renowned spirit and winter dancers, skilled canoe builders, and master surgeon and salmon fishers. I also wish to acknowledge that we have folks joining us from all over the province today, and I wish to recognize the nation from whose land you are on today and acknowledge that they are the caretakers of our beautiful homes since time immemorial. I wish to share my gratitude to be able to live and raise my family here and my commitment to my personal journey of reconciliation. I want to begin today by introducing our presenters and our administration team and give you an overlay of how the session's going to run today. We have presenters from 3 different technologies today. First, we have Hamid Othernush. He is a senior safety officer of boiler, pressure vessel, and refrigeration technologies. We have Ryan Milligan, who's a senior safety officer for gas. And we have Don McGregor, who is a safety officer for electrical in the Lower Mainland South region. For administrators, I'll be your moderator, as I mentioned. My name is Karen Stainton. And we have Cecile Caswell in the background, who's there for our administrative support. She will be supporting you through chat with any technical issues that you have. Just to give you an overlay of Zoom webinar, I know many folks have used Zoom meeting at this point, but Zoom webinar is slightly different, so there are a couple of features to know about. One important feature is that all of the attendees do not have microphone access. So in order to ask a question, you need to do it through the Q&A feature. So there's a couple of different places that you can ask technical questions. One is if you're having problems with Zoom or anything having to do with the functionality of the webinar. That goes in the chat, and Cecile or myself will respond to you. If you have a question for one of our safety officers or regards to the presentation, that's actually going to go into the Q&A section. And there you'll have the option to just put your question in with your name, or you can question anonymously as well. And we will get to as many of those questions as we can today. Any questions that we're not able to answer, we will be compiling an FAQ document, which we'll have available in our Learning Center along with this recording after the fact. Also, if you do prefer captions, you're welcome to hit the Show Captions button, and it will provide captions for you of everything that we are saying, so you're able to read the screen. Finally, if you want to adjust the way you are seeing the webinar, where the picture appears, things like that, use this little icon View in the top right-hand corner, and that will help you do so. If you have any additional Zoom questions, once again, reach out in the chat and we will be able to assist you. Technical Safety BC, we regulate 7 different technologies here at Technical Safety BC. Those technologies are electrical, gas, boiler, pressure vessel, and refrigeration, elevating, railway, passenger ropeway, and amusement devices. Our main functions are to license contractors, certify individuals. We issue installation and operating permits, approve product designs, investigate incidents, enforce, audit. We inspect based on risk, and we educate, which is what we're doing today. If an incident does occur, it's important that we're reporting it within 24 hours to Technical Safety BC. We have both a form on our website as well as a toll-free number that you can contact with any incidents. It is important to note that while we do try our best to ensure that everything we put in every presentation is the most up-to-date and current information, if for any reason there is a conflict between what is taught in this presentation and any of the acts on the screen, those acts do take precedence. So in today's session, we're going to be discussing a breakdown definition of what a heat pump is, whether or not it falls under regulation, and the requirements for the three technologies of boiler, pressure vessel, and refrigeration, electrical and gas, and we will also briefly discuss approved certification marks. Now that we've gotten kind of the intro over with, I'm going to pass it on over to Hamid to explore a little bit deeper into some of those regulations. Go ahead, Hamid.
Thanks, Karen, for a great introduction to this webinar and also introducing Technical Safety BC. So as Karen mentioned, we're all gathered here to go over regulatory requirements of heat pumps. But let's begin with why we're even talking about heat pumps. Karen, if you can proceed to the next slide. So yeah, our BC's Provincial Climate Action Plan, which is the Clean BC, is highlighting heat pumps as one of the technologies that has promises reaching our emission targets. How is that the case? Basically, let's, for the sake of our conversation, assume that we're heating up space. In order to heat up a space, we need to provide energy into this space. And there are a couple of options that we can actually provide energy into this space in order to heat it up. We can either use electric baseboard heaters and then consume as much, say, for the sake of conversation, 100 kilojoules of energy to heat up this space. So we can actually use, assuming that we are dealing with 100% efficient electric baseboard heaters, we can actually provide that through the means of electricity. Or assuming that we have a 100% efficient boiler or furnace, then we can actually produce that energy by means of burning fossil fuels. But another option is that maybe we can tap into some available free sources of energy, such as ambient or like geothermal, and then only pay to move that heat, that 100 kilojoules of energy into this space in order to heat it up. Which means that like we're going to be saving tons of energy. Like say that if we are only paying about 70 kilojoules of energy to move this 100 kilojoules from ambient or geothermal into the space, we're already saving up to about 70 kilojoules of energy compared to even those 100% electric or fossil fuel burners. So as you can see, there is a really great potential for energy saving. And for that reason, different layers of government are promoting incentives for installation of heat pumps. And because of that, there is an interest within the public, and owners are interested in installation of heat pumps in their buildings, whether it is residential, commercial, or different type of occupancies. So for that reason, we have to be mindful of making sure that we're following the regulatory requirements, whether it is the BPVR or gas or electrical requirements, in order to end up with a safe installation of really this great technology that has promises for energy saving as well. So before we begin talking about regulatory requirements for heat pumps, let's look at how a heat pump and refrigeration system is defined within the regulations. At this point, I'm only going to be talking about how a refrigeration system is defined from the boilers, pressure vessels, and refrigeration safety regulation point of view. And the reason for that is that I would like to tie the heat pumps into the refrigeration systems. So under BPVR safety regulation section 2, a refrigeration system is defined as an assembly of refrigeration equipment, and it includes a pressure plant connected to it. But what is a refrigeration equipment? It is also defined within the regulation in section 1 as machinery in which refrigerants are capable of being vaporized, compressed, or liquefied. Basically, evaporators, compressors, and condensers are considered as refrigeration equipment, and any assembly of such equipment is then considered a refrigeration system. So what about heat pumps? Heat pumps are also, as we all know, an assembly of compressors and multiple coils, whether they are condensers or evaporators. So basically, they are also an assembly of refrigeration equipment. Therefore, technically, they are also refrigeration systems. The way that they work is that by reversing the flow of refrigerant during the winter time, the coil that is installed indoor is acting as a condenser, and the coil outdoor is basically acting as an evaporator, extracting heat from outside and is dumping it indoor to provide heating. And in the summertime, the flow is going to be reversed, and the functionality of those two coils are going to get reversed. And we're going to be extracting heat from indoor, dumping it outside to provide cooling. But at the end of the day, it's also an assembly of refrigeration equipment. Therefore, a heat pump is also considered a refrigeration system. So is it then a regulated item? From the boilers, pressure vessels, and refrigeration point of view, we have just established that a heat pump is a refrigeration system. The Safety Standard Act under Section 2(1)(b), the item X of that section is basically listing refrigeration systems and refrigeration equipment as a regulated item. Also, we know that like most of heat pumps, almost 99.9% of them are running on electrical energy. I'm only leaving about 0.1% out because technically you could have an internal combustion engine to operate the electrical motors. But leaving that one out, almost the majority of heat pumps, especially the ones that we're talking about residential or like commercial applications here, are operating on electrical energy. And because of that, they are also considered an electrical device. And based on that very same section under the Safety Standard Act, the item 4 is considering an electrical device also as a regulated item. So as you might have noticed, that very same unit, i.e. the heat pump, can be considered a regulated item from different aspects. It can either be a refrigeration system, which is then considered a BPVR regulated equipment, or it can be an electrical device, which is then an electrical regulated item. Because of that, there are different sets of regulatory requirements, which I will be going through the BPVR, boilers, pressure vessels, and refrigeration regulatory requirements, after which I will pass it on to Don to go over the electrical regulatory requirements. And at the end, Ryan is going to be talking about any gas regulatory requirements applicable to the installation of heat pumps. So boilers and pressure vessels regulatory requirements. We now know that heat pumps are in fact refrigeration systems, but are all refrigeration systems considered as regulated and are subject to the requirements of boilers, pressure vessels, and refrigeration regulation? The short answer is no. Well, Section 3(2) of the regulation is listing a list of regulated equipment that are not subject to the requirements of this regulation and are exempt from these requirements. When it comes to the refrigeration systems, item J of that exemption list is basically saying that any refrigeration plant with a capacity of less than 5 kilowatts of total prime mover nameplate rating is exempt from our regulation. Please make note that we are talking about the total prime mover nameplate rating, i.e. the kilowatt rating that is stamped on the nameplate of the electric motor connected to the compressor. This is not the cooling capacity of the heat pump or heating capacity of that heat pump when it's used for heating application. Another type of, so anything that is less than 5 kilowatts, regardless of what type of refrigerants or in which occupancy it's installed, is actually exempt from the regulation, from the application of this regulation. It might still be subject to other regulations, such as electrical, or maybe even municipalities are having some jurisdiction and oversights on this one. But like BPVR technology side of Technical Safety BC is not overseeing those type of heat pumps. In addition, any heat pump of any kilowatt rating, as long as they're not containing flammable or toxic refrigerants, i.e. as long as they only have one type of refrigerants in them, and they are located in buildings that are containing 4 or fewer self-contained residential units, basically houses, duplexes, triplexes, and fourplexes. It does not include row houses or townhouses or condos. Then in those cases, regardless of the kilowatt rating, those type of refrigeration systems are also exempt from the application of this regulation. And the third type of refrigeration system that are exempt from these regulations are those that are installed on moving vehicles, such as railway cars, or like RVs, ships, the aircrafts, like different type of anything that is moving and has an air conditioning or refrigeration system installed on it. That type of system is exempt from the application of this regulation. Well, we've been talking about the nameplate rating of the compressors. What if I have multiple compressors installed on the same system, and either one of them or like all of them are going to be less than 5 kilowatt? Is this unit exempt? Well, the answer is that no. Section 46.1 of the regulation basically says that for the purpose of this regulation, the capacity of a refrigeration plant is the total kilowatt rating of all refrigeration equipment prime mover nameplate ratings connected to the same plants. It means that like if you have multiple compressors installed on that very same plant, you need to add up the nameplate kilowatt rating of all of them. And if the sum is more than 5 kilowatt, it is a regulated refrigeration system. Well, what about the nameplate does not have the kilowatt rating? We know that it's hermetic compressors or semi-hermetic compressors, for example, do not have the kilowatt rating stamped on the nameplates. In order to address this ambiguity, Technical Safety BC has issued a directive back in 2013. I encourage everyone to take a look at the entire directive. It does have enforceable, valuable information that are detailed within this directive. But basically, the summary of this directive is saying that in the absence of such nameplate kilowatt rating, we're going to be working with the information in hand, i.e. the number of phases, is it a single phase or a 3-phase motor, voltage, amperage, and please make note that the amperage is talking about rated load amp and not the operating amp. This is the RLA that is stamped on the electric motor. And then the power factor and also efficiency of that motors, then either one of these formula are going to be used to calculate the kilowatt rating of that specific motor. And then you do the same thing for all of the compressors and sum them up in order to see whether or not it is more than 5 kilowatts. Well, okay, I've done all my homework and have come across, or I now know that I'm installing a heat pump that is more than 5 kilowatts and is considered a regulated refrigeration system. Now, what type of regulatory requirements are applicable? Again, we are not going to be able to list all of the applicable requirements of the regulation. This is just a few. I highly encourage everyone to take a look at the boilers, pressure vessels, and refrigeration regulation, which is available online. But as a highlight, let's start with who can even install this heat pump. Section 57 of the regulation says that a person must hold a contractor's license in order to perform regulated work for which either servicing or installation of this heat pump is considered regulated work. So basically, you need to have the company that is installing this heat pump must be a licensed contractor to install this regulated heat pump. What kind of license we need here? Section 60 is listing applicable different classes of licenses that are applicable to BPVR technology. And item B is introducing class ref that is applicable to refrigeration systems. The regulation does not elaborate on the scope of these licenses, but Technical Safety BC has issued a series of bulletins and guidelines. The one for class ref is basically limiting the scope of class ref to installation, repairs, and servicing of refrigeration systems, installation of any refrigerant piping or pressure piping associated with that system, and also installation of pressure vessels associated with that refrigeration plant. But in addition to having a class ref contractor's license, the individual, the employee who is going to be either servicing or installing this heat pump also needs to have certain type of certifications. Section 5 basically says that that individual must have a fourth class power engineer certificate of qualification, or must be a refrigeration mechanic. Again, this is only from the boilers, pressure vessels, and refrigeration point of view. You may also require other type of contractor's license or like qualifications from the electrical or gas point of view, which Don and Ryan are going to be talking about in the further slides. And then when it comes to permitting requirements, you do need to have Section 62 basically says that you need to obtain an installation permit in order to install or repair any refrigeration system, including heat pumps, obviously. And how many refrigeration installation permits you need, even if you're installing like in the same day, you're installing multiple heat pumps at the same address, you need as many number of installation permits as the number of heat pumps that you're installing. You cannot basically install multiple heat pumps under the same installation permits. As long as they are independent from each other, even if they are installed at the same address, same location, you need to obtain individual installation permits. In addition, the owner also might need an operating permit in order to operate such heat pump. And then when it comes to applicable codes, the schedule section of the regulation is listing all of the adopted codes that are applicable to boilers, pressure vessels, and refrigeration technology. You might want to take a look and then look at the scope of either one of those adopted codes and see which one is applicable to this installation. But most likely this installation will be subject to the requirements of CSA B52, which is the mechanical refrigeration code, CSA B51, which talks about boilers, pressure vessels, and pressure piping code of construction. And then if you are doing any refrigerant piping, you might also need to follow the ASME B31.5 requirements. But as I mentioned, please take a look at the schedule section and apply any applicable codes to your installation. At this point, I will pass it on to Don to talk about the electrical requirements.
Thank you very much, Hamid. That was a lot of excellent information on the mechanical side of things for heat pumps. So as Hamid noted earlier, there are some significant exemptions to permitting requirements for heat pumps under the boiler and pressure vessel regulations. But with electrical, there are almost always applicable regulatory requirements for the electrical installation of heat pumps. So to complete the electrical work required for a heat pump, an individual must have one of the following: either an electrical qualification from Skilled Trades BC, or be a refrigeration mechanic with an electrical refrigeration FSR qualification, or there are some other individuals who are identified in Electrical Safety Regulation Section 4. In any of these cases, you must be employed by a licensed electrical contractor under a permit or appropriate electrical operating permit holder to be able to perform that regulated work. So who are these other individuals identified? The main one is a homeowner. A homeowner may perform work on the electrical installation for a heat pump under ESR Section 4, but only for a single family dwelling. One of the other main people identified under ESR 4 is a manufacturer's technical representative who can perform work on a heat pump unit. Go to the next slide here. So in the case of units under 5 kilowatts, an electrical permit may be the only required permit, depending on the gas work that's required. So if you're an HVAC company that's installing one without an electrical license, I would recommend strongly that you don't assume the electrical contractor that you're working with has an electrical installation permit. Ask them to provide the permit number to you. Often the customer is dealing with the HVAC company directly, and they can be left with no proof of a permit if the electrical contractor doesn't obtain and provide one. This can occasionally cause issues for the customer with insurance requirements or with Technical Safety BC. A refrigeration mechanic that I mentioned earlier can potentially install low voltage control cables. We see this a lot, but they must be reviewed and declared by an FSR under the electrical permit. You want to ensure that you have the discussion with the electrical contractor and confirm they're taking responsibility for that control wiring, or a separate installation permit's required. And remember that even if a pre-wired disconnect is present, a permit is still required for connection of the heat pump to the disconnect. It's already there, but who will ensure that the connections are made properly to the disconnect? Who's going to confirm that the wire and overcurrent or breaker sizing are code compliant? You need a qualified person to perform those tasks, and it needs to be under a permit. So the refrigeration mechanic certification is a unique one. It's our Class BR refrigeration field safety representative. This is a qualification that's restricted within the Class B electrical FSR category. And if you hold this certificate, you may make declarations on behalf of your employer for regulated electrical work with respect to electrical installations for equipment like refrigeration equipment, air conditioning units, heat pumps, and chillers. To have this certification, you generally need one of the following: either a Canadian Interprovincial Standards Qualification, or an IPSE as it's known certificate in the trade of refrigeration and air conditioning mechanic, or a BC certificate of qualification in the trade of refrigeration mechanic. Now, you still must apply to Technical Safety BC for this Class BR certification. You'll have to write an exam before you can undertake electrical work. It's a common misconception that this is just automatic, that if you hold that refrigeration mechanic certification, that you can do the electrical work. Well, you may have had training on it. You still have to have that exam and an official certificate from Technical Safety BC. So regulated electrical work. Again, anytime electrical work occurs, even minor, it's considered regulated electrical work and a permit is required. There are some exclusions for not obtaining a permit, which are covered under Electrical Safety Regulation Section 18. The key ones that relate to this is no permit is required if the only electrical work performed is testing, like we see in the photo here. Or also a qualified individual may replace the following regulated products without a permit, up to a maximum rating of 150 volts to ground. So that's things like receptacles, cord attachment plugs, snap switches, ballasts, fan speed controllers, thermostats, or overcurrent devices or breakers. So some common things where we're just doing a re and re. Also, I mentioned the manufacturer's technical representatives earlier. So they could perform repairs involving the components of existing installed and certified regulated electrical equipment, such as a heat pump. But that would only be if there are no modifications or additions to the electrical installation, and if the characteristics of the regulated equipment are not altered. So basically swapping out parts in an existing certified heat pump in our scenario here. Thank you. So in addition, now that we've talked about all these requirements for when you need a permit and who can hold that permit, there's additional things to consider when installing a heat pump because it's a significant load. Service size being the main one. In the case of a single family dwelling, is the service that existing large enough to handle that load? An upgrade to the electrical service could be required. Energy management systems are currently not recognized in the BC Electrical Code for reduction of demand load. We have a recent bulletin that's come out, IBEL 2023-01, which provides some clarification on Rule 81068 on how additional loads like hot tub, electrical vehicle supply equipment, or a heat pump could be added to the existing service of a single dwelling unit, only a single dwelling unit. BC Electrical Code Section 8 that talks about circuit loading and demand factors does not permit the installation of electrical equipment, heat pumps, or for example, or assist other systems other than electrical vehicle energy management systems if the calculated load or demonstrated load exceeds the rating of the distribution equipment, feeders, conductors, services. And electrical equipment like a heat pump must be calculated at 100% load based on the nameplate rating of the equipment with any other applicable demand factors. An energy management system product that was certified for use and installed as per the manufacturer's instructions must still fall within the provisions for switching of loads that have been identified in several code rules such as 8106, 2, 3, 5, and 9, which basically deals with the fact that this management system would have to ensure that only one load can be on at one time in order to be code compliant. The bulletin I mentioned, 2023-01, addresses augmented loading for a dwelling. This calculation is based on highest hourly intervals provided from the utility for the most recent 12-month period, with a service factor of 25% to allow for peak usage within those hours. You would then take an additional load, such as a heat pump, and add that with demand factors by the code to see if the existing service is adequate. This can be really helpful in a lot of cases where a traditional load calculation by Rule 8200 would show that your service is not capable of handling that heat pump. If you can take that peak loading provided by hydro and do some calculations there, sometimes you can actually add a little bit more load on there, but that's only for single family dwellings. I would highly recommend reading that bulletin. There's some good information in there. It's very clear and straightforward what you need to do as an installer, and it can really help people out in a lot of cases. If the home that we're looking at heat pump installation in is a multifamily dwelling, like a townhouse, a row house, a duplex, there are a lot of additional factors relating to load calculations for both the individual unit, the feeder, the sub-feeder, and the main service that need to be considered before establishing if a heat pump can be installed. Again, we have an older bulletin on this one, 2014-01, which gives examples of how to perform load calculations for multifamily dwellings. It'll be a likely requirement if you're installing a heat pump unit at a multifamily dwelling that you'll have to provide these load calculations. You always need to remember that heating and cooling loads like a heat pump must be added to any feeders or the main service at 100%. There's no derating per unit similar to other added loads in an individual unit. This is due to that there's no variety of loading. The temperature outside makes heating and cooling cycles generally the same for each unit. It's not like other equipment in the unit that may vary from one place to the next. One or two units of adding something like a heat pump may not be a problem for the main service, but more than that, and a whole complex may need an upgraded infrastructure system. Management systems are a recent tool that have come out a lot, but management systems that do not monitor the main service and feeder conductors do not allow for reduction of the demand load on the main service and are currently not accepted under the code for heating and cooling systems. So the heat pump would still be included in the loading to the service at 100%. So strata considerations are another issue in multifamily dwellings. There are additional strata requirements that need to be investigated before moving forward with an installation. And you want to ensure that you're budgeting time for your customer to investigate requirements with their strata. So owners, councils, and contractors must be aware of the process to plan and install electrical infrastructure in these strata housings. Corporations for stratas for buildings like duplexes, condominiums, and townhouses are governed by the Strata Property Act and bylaws, which require an owner, occupant, or tenant to obtain written approval of the strata corporation before making an alteration to a strata lot or the common property. And this includes the installation for things like heat pumps or electric vehicle supply equipment due to bylaws about alterations and laws regarding insurance. The Vancouver Island Strata Owners Association is an example of one of the organizations that has begun sharing resources and links to assist strata owners and councils in steps for installing these types of equipments. On December 6th, 2023, there was a new order in council, 67123, that was brought into effect, a requirement for strata corporations to obtain electrical planning reports. This new order also contains regulations that provide details about these requirements. So when we're looking at that, what is an electrical planning report? This is a report to help strata councils and owners understand their electrical system and assess whether their buildings have electrical capacity for future needs. For example, if your strata has a gas boiler, at some point you're not going to be able to replace it with another gas boiler, which could obviously lead to a large electrical need. The Clean BC Roadmap to 2030 sets out a commitment to ensure that all new space and water heating equipment sold in BC after 2035 will be 100% efficient. So whether a strata's corporation's goals include cooling, heat pumps, electrical vehicle charging, or electrification of other fuel building systems, this electrical planning report is a really important tool to help plan for the future and avoid costly electrical service upgrades. Our last sort of requirement here is related to the gas side of things, which is a heat pump's outdoor units and the safety disconnects that are associated with them are considered a source of ignition. And they must be installed in accordance with the clearance requirements that are laid out in the BC Electrical Code, Rule 2-38, which references the B149 natural gas and propane installation code. Basically, what the outline is that disconnect or that unit that are sources of ignition must be 1 meter clear of vents for natural gas and 3 meters for propane gas. With that note on the gas requirements, I'll pass this over to Ryan to talk about the regulatory requirements there.
Awesome, thanks, Don. Some pretty important considerations when you're looking at installing a heat pump in terms of the electrical requirements for these heat pumps. As we can see, there are a lot of considerations when you're looking at heat pump installation in regards to regulated refrigeration equipment, whether or not the piece of equipment falls under the regulation or not, as well as electrical. There are some regulatory requirements to consider, some very important considerations as Don's gone over. I wanted to take a few minutes to go over some of the impacts on the gas systems or gas equipment. As a lot of us know, a lot of you on the call will know that heat pumps are very closely related to HVAC equipment that may be gas equipment. And there could be some implications on the gas system or gas piping system or gas appliance installation that need to be considered. So unless the heat pump is driven by natural gas, the residential heat pumps are not considered gas equipment, and therefore they're not there are no gas regulatory requirements specific to the residential heat pump, such as permitting or gas qualifications required relating to that heat pump installation. Whether the heat pump is a standalone split unit or an outdoor unit with a coil in the furnace plenum, the heat pump itself is not considered gas equipment. If in the course of installing the heat pump, the gas appliance installation, including the piping or venting system, is being altered in any way to accommodate the installation of a heat pump, a gas permit may be required to allow for those alterations to the gas appliance installation to take place. This changes a little bit when you get into commercial rooftop package units that contain the heat pump package as well as backup heat, such as electric elements or gas heating section. All within the same package. In some of those cases, you may require a refrigeration permit for the heat pump, as well as a gas permit for the gas section and an electrical permit for the electrical connections to that rooftop unit. So that one rooftop package unit, if it's big enough to be a regulated refrigeration system, may require 3 separate permits for that one piece of equipment. So all worthy considerations when you're looking at a heat pump installation. As noted above, most heat pumps are electrically driven. There are some manufacturers looking at the technology for natural gas driven heat pumps, but today 99.9% of heat pumps are electrically driven. We may start to see some residential light commercial units in the future that are gas driven, either by thermal expansion or by like Hamid mentioned, internal combustion engines driving the compression system. So that's in the future. We'll see what happens with that. This definition of regulated work comes from the Safety Standards Act, and it applies to all technologies. But then the safety regulations, particularly the gas safety regulations in this case, goes on to define what regulated products are specifically for the gas technology. Gas equipment includes anything that is used in connection with gas and includes any of the following. It could be piping, could be appliances, could be fuel containers, and it could be vents. This means that any work done on a piping system, gas appliance, or venting system is considered regulated work. Section 4 of the gas safety regulation lists the qualifications required to be permitted to perform regulated work under the gas technology. Note, to make any alterations to or to perform any type of installation of a gas or system or gas equipment, you must be employed by a licensed gas contractor and be a Class A or Class B gas fitter. Apprentices or anybody without a gas fitter certificate of qualification, including refrigeration mechanics that don't have gas fitter qualifications, must be supervised on site by a qualified gas fitter. Installations or alterations of gas systems or equipment are also outside the scope of work permitted by gas appliance service technicians. Here's a typical example of a split heat pump system with an indoor coil that's installed in the supply air plenum of a gas furnace. As you can see from the photo, the venting system for this gas appliance would have had to have been altered in order to accommodate the heat pump coil being installed. This alteration would have required an appropriately qualified individual as well as associated permits to alter that venting system for the gas appliance for the coil of the heat pump to be installed in the supply air plenum. It's worth noting that in 2021, we had a potentially serious incident in a case of a heat pump installation exactly like this one, where an individual who did not possess the appropriate gas qualifications to perform that gas work installed a heat pump and neglected to reinstall the venting in the furnace after installing the heat pump coil in the furnace plenum. Thankfully, it was noted by the homeowner at the beginning of the heating season and reported to Technical Safety BC and rectified before the occupants were seriously affected by the potential carbon monoxide exposure. Even though heat pumps are not considered regulated gas equipment under the gas safety regulation, there are implications on gas systems stemming from the installation of heat pumps. As Don mentioned, the Canadian Electrical Code specifies clearance requirements between electrical equipment considered sources of ignition and propane storage. The B149.1 Natural Gas and Propane Installation Code and the B149.2 Propane Storage and Handling Code go into more detail on exactly what those clearance requirements are and what the distances required are. As you can see in this photo, the 10-foot clearance between the propane cylinder and or the propane relief device on the regulator was not maintained. This container shown here has a relief device on the container itself, as well as a relief device on the regulator, likely mounted under the hood of that container, both requiring 10-foot clearance to a source of ignition. The wall in between does not reduce this required clearance, and this often results in a callback of the installing contractor to try and sort out how to achieve the required clearances. Table 5.3 in CSA B149.1 Natural Gas and Propane Installation Code specifies clearances from relief device discharge openings, and Clause 6.7.2 of the CSA B149.2 Propane Storage and Handling Code also reiterates the 10-foot clearance requirement is required to a source of ignition from a propane cylinder or tank. Note the heat pump itself is a source of ignition because of the electrical devices contained within it, and the electrical disconnect is also a source of ignition. Again, the photo shown here is non-compliant with the required clearance requirements of the electrical code and the gas code. One of the problems we're seeing is that when this happens, the propane supplier is often the next person on site, does the right thing and refuses to fill the cylinder because of the hazard that was created by the heat pump installer, and then reports it to Technical Safety BC. And now it's a much bigger problem for the heat pump contractor to go back and fix after the fact. And with that, I will pass it back over to Hamid to go over a few more refrigeration technical requirements.
Thanks, Ryan. So in this section, I will be talking briefly about just a few of the technical requirements. Obviously, I will not be able to cover the entire CSA B52 in this short time. I'm only going to be talking about the design registration and certification requirements for the heat pumps from the boilers, pressure vessels, and refrigeration regulatory point of view. So CSA B52 in clause 5.1.1 is basically calling for any pressure retaining components of a heat pump or refrigeration system, i.e. the pressure vessels, pressure piping, and pressure fittings, to be registered with jurisdictions having authority, i.e. Technical Safety BC, and they need to be issued a CRN number, Canadian registration number. In addition, section 5.3.1 of CSA B52 is also calling for the entire system to also be registered with the regulatory authority having jurisdiction, i.e. Technical Safety BC, for the entire system being compliant to the CSA B52 requirements. So therefore, your heat pump must have appropriate design registrations for the pressure retaining components installed in it, and also the overall installation must be registered for compliance to CSA B52. However, the clause 5.2 has an exemption for this design registration. So it basically says that any refrigeration system that is below 125 kilowatt in total prime mover nameplate rating and is designed, fabricated, and tested as per one of the listed CSA C22.2 series standards here, and are certified by an accredited certification agency, then those type of systems might be exempt from the registration of pressure piping, pressure fittings, and also the overall system design registration. You don't need those registrations in those cases. Any pressure vessel installed on that unit still requires to have a CRN, Canadian registration number, but that's the manufacturer who is to obtain that registration. So what type of certifications are acceptable? Basically, you can actually take a look at our websites and then take a look at the regulated technologies, and under the regulatory notices, there are a series of information bulletins issued by gas and electrical technology to elaborate more on what type of certification marks are acceptable for certified units. Basically, the certified units has to be tested and certified by the accredited certification agencies that are accredited by the Standard Council of Canada. And you have to make sure that the certifying agency is accredited one and are applying the appropriate certification marks. So here are just a few examples of certification marks that are accepted here, like CSA certification mark or UL. Like for example, in case of CSA, if you see that it's CSA with a US underneath, it's not accepted. It's only applicable down in the States. Or for the UL certification marks, it must carry that little C right next to it that is going to make it applicable to Canadian version of Underwriter Laboratories standards. Also, please note that the field inspection carrying the SPE 1000 certification mark is not acceptable for packaged units. That inspection is not covering the pressure retaining components of a heat pump or refrigeration system, and it's only applicable to electrical parts. So that is not considered an acceptable certification mark for a listed packaged unit or even like a field erected unit. I'll pass it on to Ryan to talk about the summary of what we've gone through this presentation.
Awesome, thanks, Hamid. Again, a lot of information here. So just to summarize some of the key points that we've gone over in our presentation today. In terms of electrical, as Don pointed out, there are almost no circumstances where an electrical permit would not be required for an installation of a heat pump. Individuals performing the regulated electrical work also need to possess the appropriate qualifications to perform that scope of work. They must be performed by a qualified electrician or the holder of a refrigeration FSR qualification. And the electrical work associated with the heat pump installation is not included. Just a note, the electrical work associated with the heat pump installation is not included in the limited electrical work permitted by a gas fitter under the gas installation permit. We've also gone over when and where you need a refrigeration installation permit. If the unit is below 5 kilowatts, whether it's residential or commercial, then no refrigeration installation permit is required. Further information can be found on our website on how to calculate the kilowatt rating of the heat pump where you're installing, and the exemptions from the boiler pressure vessel regulation can be found within the boiler pressure vessel and refrigeration regulation available online. And then for gas, you will have to consider if the gas piping system, the gas appliance, or the venting system for a gas appliance is being altered in order to install a heat pump. If so, then a gas permit would be required and appropriate qualifications of the individual would be required as well. Some other key things to take away for commercial applications: does the product being installed require design registration? Are the product's certification marks approved or recognized in BC? Again, most of this information can be found on our website in terms of when and where design registration is required and what certification marks are acceptable for the various technologies. For residential and single family dwellings, is the service size large enough to handle the new load? Probably the biggest question that is going to come up when you're looking at a heat pump installation is the service size and the sizing of the new load on the electrical system. For residential and multi-unit dwellings, does the customer have all of the required strata approvals and documents in place to be able to install a heat pump? And has the strata provided the electrical planning reports? For more information, you can go to our website. As mentioned a few times here, there's a lot of information on our website under the regulatory notices tab. You can filter by technology and the type of document you're looking for, whether it's an information bulletin or a directive or a safety order, all of that information is available to you. You can also access each of the safety regulations and the Safety Standards Act through this tab. If you're interested in looking through the boiler pressure vessel safety regulation or the gas or the electrical safety regulation, it's all available there as well. All right, so questions, and I think I'm going to hand it back over to Karen to facilitate some of the questions as they come up on the Q&A board. Feel free to put your question onto the Q&A and we'll try and get through as many as we can in the time that we have.
Thank you so much, Ryan and Don and Hamid. I'm just going to bring you all up here. So we do have a couple of questions that have come in, and hopefully a few more will filter in as well. Just a renote here, if you are putting something in the chat, please make sure you're putting it in the Q&A, as we may not catch it in the chat. Okay, so our first question is directed towards Don. And it's, I heard you say we cannot use load sharing equipment. Does this mean we cannot use a load sharing device to share the heat pump load with an equivalent or larger load, for example, baseboard heat or the base 6,000 watts of a range?
Okay, so yes, so an approved load sharing device like a load miser or a divvy is one of the newer units, may be acceptable to be used in that circumstance. 8106 subrule 2 deals with that, where only one load may be connected at any one time. So it's load management devices that really are not, there's no allowance under the code for that. So like an existing load sharing device may be applicable. 2 load calculations would usually be required in that case, one for each unit, because something like a heat pump where it's included at 100%, if you're sharing with something like a second range or a dryer, where they're only taking it perhaps 25% in the load calculation, can have drastically different results, especially in a multifamily dwelling. But for a single family dwelling, a load sharing device could be acceptable depending on the situation.
Thank you, Don. Next one is for Hamid. Can a heat pump be field assembled with an individual components? What certification marking would be needed?
That's a great question. And the answer is yes, you can actually field assemble a heat pump with individual units. In this case, certification as per clause 5.2 most likely is not going to be applicable, because that certification, those CSAC 22.2 series of certifications are typically applicable to the line productions, not to the field assembly of the units. And in such case, you are most likely required to register either components and also the overall design. In this case, it must follow, for example, the piping must follow ASME B 31.5 requirements, and the pressure fittings and pressure piping and pressure vessels does require to have a Canadian registration number. I hope that that answered your question.
Thank you. Going back to Dawn. Same to first question. What if I replace a baseboard heater circuit at 20 amp and I use the same 20 amp heat pump? Do we need to do load calculations again?
So similar to my first answer, if it was exactly identical loads, then, and you could display that, then that might be fine without a load calculation. That would be an individual circumstance that a safety officer in the area would have to consider. But yes, in general, again, we're talking about baseboard heat versus a heat pump where they're both taken at 100%. That would, again, likely be an acceptable situation, but every individual circumstance is slightly different.
Thank you. And can we interlock baseboard heat via a conductor with a heat pump to not affect a load calculation?
So I'm thinking we probably meant a contactor there. So again, yes, there are provisions in 8106, just like we see in sometimes in multifamily dwellings now, where we would have a switch to have either the air conditioning running or baseboard heat by a contactor or something like that. That could be an acceptable solution because there are code rules that allow for interlocks of only one load being on at a time. And again, if we're talking about two heating sources, it would likely end up with the same result if we were talking even in a multifamily scenario where we'd be talking about the main service calculations. We would just have to be careful in that case, how far you're going with homemade things with a contactor or something like that, because generally, if we have any sort of control scheme and it's site or field built, we might need an SPE 1000 approval label if it's more than just one switch controlling a contactor or something.
Thank you. Hamid, can you go over again the calculation where to get the kilowatt information from?
Yes, so that calculation is actually provided within a directive that is issued by Technical Safety BC. The directive number is D-BP-2013-02. It does provide the formula for those calculations and also is detailing the nomenclature for either items used in that formula. Again, you can always reach out to us if you have any question with regard to that calculation. Again, the directive number is D-BP-2013-02.
Thank you. And Dawn, we're going back to you. Can I use loads that have demand factors like a dryer at 25% if the heat pump is equal to or less than this calculated number for a load share device?
So I'm going to read into that a little bit, and I'm assuming what the question is referencing is if you took a dryer and it was at 25%, so say 1440 watts in the load calc, and you had a heat pump that's total load was equivalent to that 1440, and you were doing load sharing with them, then again, for a single family dwelling, that would likely be acceptable. For a multifamily dwelling, still that heater, or sort of the dryer would get reduced by additional factors for how, depending on the number of units, whereas that air conditioner or heat pump would always be going into the main service calculation at 100%. So in a multifamily dwelling, that likely wouldn't work. Single family dwelling, if I'm understanding the question right, and it's a 1400 watt heat pump versus a dryer, which at 25% is 1400 watts, then yes, that would likely be acceptable.
Thank you. Our next question is a little bit more of a comment. I don't think we actually have an answer, but I'm going to read it out and we will definitely provide the feedback to Clean BC. Are you guys working with Clean BC on rebates for heat pumps at all? Currently, they don't capture residential permit numbers and make them mandatory to qualify to get the rebates. You would think one of the requirements would be to prove an electrical permit was pulled. I've brought it up with Clean BC quite a few times, but they have not made it a requirement. Currently, homeowners or contractors can do their own electrical and get a new install and rebates even without proof of a permit. From what I have seen in the industry, this is something you guys should be added to Clean BC rebates. Are you guys working with them on that at all? Ryan, you wanted to answer that one?
Yeah, I can comment on that. And I don't know if I can get very specific on the answer to that question, but we do have a climate action team within Technical Safety BC that works very closely with Clean BC on these initiatives, on the rebates and what the requirements are moving forward. And this is great input that we'll bring to that team and get them to look into it further and see if we can bring this comment to some sort of action. Of course, there is permitting requirements, whether they're interconnected with the Clean BC rebates. That's a decision that Clean BC would need to make, but we'll definitely bring this input forward. Thank you.
Thank you. And Hamid, can a homeowner install a small heat pump that has been pre-charged with refrigerant?
I will answer it probably with the help of Don to talk about the electrical requirements as well for that. But when it comes to refrigeration or like BPVR aspects of this homeowner installing this as a small heat pump, again, we have to consider whether or not it's a regulated heat pump. If it's smaller than 5 kilowatts, then it's not regulated, then you do not need to have a BPVR contractor's license or be a certified individual from the BPVR point of view to install this unit. There still may be some requirements from the electrical points, which I think Don is going to be talking about. There is also another question that was entered into the chat box, which is kind of related to this one, and that was about the 5 kilowatts. And I think the question was like a 36,000 BTU, which is like a 3-ton unit. Is it under 5 kilowatt? Again, we're not talking about the cooling capacity or BTU capacity of the unit. This is the electrical kilowatt rating of the electric motor connected to the compressor, not the cooling capacity or heating capacity of the units. I'll pass it to Don to talk about the electrical requirements of that homeowner.
Thanks, Hamid. Yes, as far as a homeowner installing a small pre-charged heat pump, that would likely be acceptable. Homeowners are able to pull permits for it, as long as you're confident and have knowledge of the work and can read the service sizing. That would be the only thing I would like to note at that point, is that homeowners, when obtaining electrical permits for this, often struggle with one of our requirements on the permit, which is performing a load calculation of the service. And as we talked about today, heat pumps can be a significant load, even smaller ones, because they're taken at 100%. So you need to be able, as a homeowner, to perform that load calculation when you apply for the permit and show that you know that the loading is acceptable.
Thank you. Well, I want to thank everybody for attending today. As we are 3 minutes over the hour, we are going to stop there, as we did clear the questions before any more come in. Should you have any additional questions or comments, our contact email is on the screen to contact us, and they'll be filtered to the appropriate individuals. We have been recording this session and we'll be posting it up in our Learning Center, as well as an FAQ document with questions that have come up in this session and in other sessions we offer. Thank you so much for attending today, and have a wonderful afternoon.